Hey there. Are you tired of waiting for the next episode of It's Probably Not Aliens? Well, we've got some good news for you. On Nebula, our streaming service, you can get access to all our episodes a week early. That's right, you'll never have to wait again to hear Scott and I debunk the latest ancient astronaut theory or get a movie fact wrong. But that's not all. Nebula is home to dozens of content creators we know you like, so you can find all your favorites in one place. Plus, we post content on there that you won't find anywhere else. And the best part? By signing up for Nebula at nebula.tv/probablyNotAliens, you're directly supporting the show and both of us. So don't wait any longer. Join Nebula today and listen to the next episode right after this one.
I have a question 150 episodes in. I don't know if it's just me, but when I'm referring to our podcast, especially internally to myself, I always just call our podcast IPNA. Do you do that?
Yes, but I just think IPNA. I don't
IPNA.
I don't go IPNA.
I say IPNA all the time.
It's good.
Maybe not even out loud, but I say it in my head. I go when we're like writing, I'm writing folder names when we're like getting our files, and I just write IPNA episode, blah, blah, blah. I just think of it as IPNA. I know most everyone probably thinks of it, the shortened version is Probs Not Aliens, which is also good. But I need to know which group people are in. Are you Probs Not Aliens or are you IPNA? I gotta know.
You're going to name your child IPNA, so we have to make if this wins, if the poll wins.
My child's name is going to be IPNA. My child's name will be whatever the polling is.
Yeah.
If it's IPNA, it's
if
IPNA.
Probs Not Aliens.
If it's Probs Not Aliens, that's going to be even weirder and harder to explain. IPNA, I could always just say, I don't know, it's a family name. Technically, because it's from my podcast that I am a co-host of. But I think I may have mentioned this in a previous episode. I get a kick out of non-alcoholic beer, specifically non-alcoholic IPAs, because sometimes they will be abbreviated as IPNA,
Ooh.
Indian Pale non-alcoholic ale, I guess.
Oh man, I gotta get me some of those just for the branding alone.
I know. I see them in my local co-op every so often. There'll just be little IPNAs. And the N is also special, like ours, because it's supposed to be IPA, and there's like a little N, IPNA, just like our show.
Okay, so if there is a brewery that makes a really good IPNA and you are looking for a natural collaboration opportunity,
Yes.
I mean...
Hops Not Aliens.
Hops Not Aliens. Yeah, there you go.
Come on!
Reach out somebody. I love me an IPA, so I would, and I also would love to help people in recovery. So, yeah.
Absolutely. Let's make a non-alcoholic IPA about aliens. Hops Not Aliens. Sometimes these intro things are just bits that we do for fun, but I'm 100% serious when I say I would love to have a non-alcoholic IPA.
Yeah.
With our branding and everything. Please get a hold of. Please email us.
Yeah. I'm very limited on what merch I want to do because anybody can do a t-shirt and we should do a t-shirt. But
anyone could do that. We haven't though, but we could if we wanted to.
But the two things that I definitely have been completely sold on right now. 3 things. I want a space potato squishmallow.
Yes.
And I want Scott and Tristan bobbleheads.
Yes. All right. Yes.
And now
with
I
mine
want
being extra tiny.
Yes.
The opposite of a bobblehead with a really large head. Mine just a really tiny head.
Yeah, it looks like what's it called? The lizard thing from the 90s Mario movie.
Yeah, 100%.
And then now a branded non-alcoholic IPA.
Yes. Please reach out. I have so few things in my life, I say as I'm about to become a father. I have so few things in my life. I need this. Please.
Your child needs to look up and be proud of you by showing the bobblehead. And
I need the bobblehead. I need the space potato plushie will be great for child. And look, the child can't drink alcohol anyway. Give it a beer. Give it a non-alcoholic beer.
Yeah, I mean, why not? That's the real question.
Why not?
It's mostly that kids would hate the taste of beer, but yeah.
It's mostly that.
Yeah.
We're not talking about beer or anything today. This is a podcast, though, that doesn't have any beer branded.
This is called India
Pale
Pale Non-Alcoholic Ale.
Correctamundo, where we debunk ancient astronaut theory, ancient aliens, all that good stuff. We're wrapping down this season of our show all about... Wait, hold on. I have it still loaded on here.
How do you move it?
All about...
unexplained structures.
So we're gonna get into that. But my name is Scott. I'm one of the co-hosts. I know nothing. I don't know anything. Except for last week, I knew a little bit of something. And all that information's gone now.
You did your ritual purging of your mind.
That's right. I soaked it all up. My head was nice and big and juicy with information. I squeezed it all out to have a normal, tiny-sized head.
That's how it works.
My
name's Tristan Johnson, and I will say I learned more science for this episode than I think I have for any other episode before. So
that is saying a lot. I guess typically we do hand it off to like Isaac Arthur, right?
Or somebody, some science
person. Or some science person, but you did it all yourself.
Yep, and so almost guaranteed we'll be talking about this in a future episode with all the corrections.
We're trying our best, okay? We're trying our best.
We're struggling.
Yep, I had it pulled up before you could say it. Oh, it was good stuff.
But we are also, this is one of those, like, you know how like today everything with nostalgia is popular? This is a nostalgia episode for a few of our banger classics, so...
I love it.
Because this is kind of returning...
I think I have a flashback sound effect, too.
Okay.
That's not very nostalgic sounding, but it is flashbacky.
Well, all right, everybody. We are going back to Carnac.
Back to Carnac.
Because this episode of Ancient Aliens decided that we needed to go back to Carnac.
I was gonna say, as soon as I loaded up the notion sort of bullet points for this episode, I was like, oh yeah, let me just Google image search Carnac really quickly, and I was like, no, we've done this. We've done this before. We certainly have.
Yes, but we're gonna do a little bit about. We're not gonna debunk Carnac so much as debunking the specific claims that they made about Carnac, and also tying into world grid theory and kind of where those two intersect, and get into the physics of everything that I don't think we did last time. So that's the whole idea. So first of all, before we go too deep into the meta, because also you might not have seen that episode or listened to that episode before.
Yeah.
It was done a couple years ago, as far as I recall. And so in Brittany, in France, Brittany being like, if you can picture the shape of France in your head, the little peninsula that juts out in the northwest part of the country.
Oh, I love that part.
That's Brittany. So Carnac is a village in Brittany, and it is made up of 3,000 standing stones. It's actually the largest concentration of such megaliths in the world.
Whoa. That's awesome.
Yeah. They're very old. They were erected in the Neolithic era, which is, between like 5,000 and 6,000 years ago.
Mm-hmm.
And it is made up of these long rows of things called menhirs, or standing stones, or dolmens, tumuli, or other kind of stone circles. So here is what their words are, kind of claiming what is odd about these stones.
What do millions of people around the world believe?
Because last time we just talked about them being placed in lines that align with stars and the Earth grid and everything. But did you know that these that these granite stones are rich in quartz, which basically makes it a giant battery?
Oh my gosh.
Because the Carnac stones are said to be rich in quartz, and it's magnetized with the Earth, which implies that they were intentionally shaped and oriented to interact with the geomagnetic forces of the Earth, rather than just a symbol or a ritual object.
Of course. They're pulling double duty.
Mm-hmm.
They've got these energy fields and these they're lined up so perfectly. They're some sort of cool battery. This all works for me.
Yep. And what is the purpose of this? According in the Ancient Aliens episode we watched, that they were a, quote, GPS system for extraterrestrials. The quartz content, the magnetism and the geometry and scale of the site, that the stones are a geomagnetic power plant or a navigation beacon, which they liken to a GPS or an airport signal that extraterrestrials could use to navigate the planet.
All right, cool. I have 0 follow-up questions about that claim. Nothing comes to mind about why extraterrestrials who presumably have faster than light travel to come to Earth needed to build this thing out of
a runway
stones.
Yeah.
Yeah. Just it all makes sense. It all tracks for me.
And one of the things that they built this with that they wouldn't have had access to is knowledge of a Pythagorean triangle. So the stone's alignments were claimed to have formed large-scale geometric patterns, including Pythagorean or right triangles that span miles, which proponents argue implies that they had advanced mathematical knowledge far in advance of what Neolithic people should have had.
Right, all the way before
Pythagoras. Yeah, long time before Pythagoras, thousands of years.
Man, that's pretty impressive.
Yeah. So they claim that this site is a geomagnetic power plant, a machine that broadcasts radio energy or energy over the air. And you can see that it is meant to be seen from the sky, which leads the claim that it is functioned as a signal or a marker for airborne observers, which means that,
that's a classic. That's a classic claim. That all the, anything this big or this long has to be viewed from the sky. Must be. It was intended to be. Mm-hmm. So therefore aliens.
Yeah. And of course, it's all aligned with a bunch of other things, which means that it's a part of world grid theory. The Earth is a D20.
Yes, let's go.
Yeah.
This is nostalgic. You're right.
And the thing is that there is seductive logic to this. Like, you look at lines and you look at the design of the site and we don't know what it does. But, you want them to do something. You want to find out that there's like some kind of function to it. Yeah. Because otherwise, why would they go through all the effort? So that is the main claims, right? We're gonna go break these down one by one about the stones being rich in quartz, making them a battery, it being a GPS system for extraterrestrials, and that they were magnetized with the Earth, Pythagorean triangles, that kind of thing. So,
lots of stuff to break down. I'm excited.
Yeah. So let's first look at the full claim of the site being a battery. So here's the claim: that this granite is full of quartz. Quartz being a word for just basically like crystal. Like if you ever look up your generic clear / white crystal, that's usually quartz.
Yeah.
Quartz is what's called piezoelectric, which makes them into giant batteries. They're made of granite, which contains significant amounts of quartz. The quartz being piezoelectric means that it can generate an electrical charge when it's subjected to pressure or stress. Mm-hmm. And because the stones are massive, tightly packed, and subject to constant earth pressure vibration, the geomagnetic forces would theoretically activate this piezoelectric property. The stones are described as magnetized and deliberately shaped, often tapering to points. which is claimed to enhance their interaction with Earth's magnetic field.
Like a funnel.
Yeah, exactly. So their precise alignment and large-scale geometric layout is argued to allow for individual stones to function together as a single system rather than as isolated objects, and for specifically as a system for storing, amplifying, and transmitting energy, effectively turning the site into a giant battery or a power plant rather than, say, like a ritual monument. And
This is a little tricky because I understand I understand what I think they mean by energy, but the issue is it's a different thing than what people might think. Their ancient aliens' energy is like I don't even know how to describe it. It's just like it's like not a measurable thing.
Magic.
It's just like energy.
Magic.
It's magic, is what
Yeah.
they're saying.
Yeah.
Because like if these things were generating electricity, as what you might think of when we think of energy, you know, like, oh, it's generating electricity to power stuff. Surely we'd be able to measure that. But no, this is energy, which is different. And we can't measure it. You just have to trust me.
Yeah, energy is typically defined as an object's ability to perform work, which is hard to, it's hard to put that in. But let's kind of break this concept down. So the main thing that they're doing here with this piezoelectric claim and this whole stuff about quartz and the magnetic field of the Earth is that they're making a false equivalency or intentionally mixing up what's called paramagnetism versus what's called ferromagnetism.
Ah, okay.
So we'll just start with magnets. How do they work? What the fuck is a magnet?
How do they work?
Yeah. So magnets.
Well, are we finally going to answer this question?
Yes.
It's been 150 episodes. We're finally going to answer how magnets work?
Yeah. So magnetism, or by its more accurate name, electromagnetism, is one of the fundamental physical forces of the universe. And it is a force that's created when you have electrons or spinning electrons moving through different materials. It causes materials to attract or repel each other. And the region around a magnet where these are moving is called a magnetic field. So this is how it works. If you were to think of an electron, or if you were to think of an atom, right?
I'm thinking Adam Scott.
Yep.
Personally. What's in your head? Which atom is in your head?
Driver.
That's a good atom too. We got two good atoms here.
Yeah, except it's a bit big for an atom. So surrounding these atoms are what are called electrons.
Okay.
These are extremely, like, we're literally talking about almost the most like fundamental building blocks of reality.
Yes.
And so every atom has almost like an orbit of electrons. That's a little bit of a misnomer because it's actually like a probability wave field duality thing that I can't really describe. And I probably have already made physicists roll their eyes even by describing it like that. But for the sake of simplicity, if you think of every atom as having these shells around them with electrons that are kind of in orbit, in different levels of orbit.
Yes. They've got shells, so they melt in your mouth, not in your hand.
Exactly.
Okay.
And when there is, you can create a flow where electrons leave one atom and move towards another, kind of like a flow of energy. And when that happens, that is like electricity as we know it, like electricity moving through things. But, and because all of the movements of those little electrons create tiny magnetic forces. But if you have an object where either because of electricity flow or because of the nature of the material, you have a bunch of electrons spinning in the same direction, those little forces add together, and if you have that creates a force, and if that force is pointing in the same direction as another one, they will repel each other. And if they're opposite, they'll attract each other.
Yes. I'm familiar with this.
Hmm. So that's
Opposites attract.
That's what a magnet is. A magnet is like an object where the material of it has the electrons like sort of spinning in the same direction, so they can create powerful magnetic forces like that. This is why the most powerful magnets that we can make in the world would be like superconductors, where the whole idea is that there's basically no electric resistance, so the electrons can flow freely and you can make these extremely powerful magnets. And that's like the kind of stuff that you use to make like maglev trains and MRIs and like
Cool.
fusion machines. And the only problem though is to make it work, to make the electrons flow that freely, you have to get it almost to absolute zero, like the coldest temperature imaginable. You need to be like, which means that these things, like for example, one of the big challenges of making a good fusion reactor is that you need this combination of the most powerful magnets that you can possibly make, which need to be kept at like extremely cold temperatures, like near absolute zero, right next to the theoretically could be the hottest temperature in the universe, multiple times hotter than the sun. And having those two next to each other turns out to be a very difficult, and using magnets, only magnets to separate them, is tricky. Yeah,
it is tricky. Heat miser and snow miser don't get along too well, even though they are brothers.
Well, you have to have those brothers get as close as humanly possible and not kind of destroy each other.
Yes, and that's where Mother Nature comes. We're recording this over near Christmas, everyone, just so you know.
Yeah, good, get that holiday spirit. So then there's two kinds of types of magnetism. There's paramagnetism and ferromagnetism. So paramagnetism is...
That sounds, Tristan, I don't want to be pedantic, but that sounds like there's three, right? There's ferromagnetism, and then there's this other paramagnetism. That's two magnetisms in a pair. Two makes a pair, Tristan.
I have to go. Yes, so here's the idea, is that paramagnets are weakly attracted to magnets, while ferromagnets are strongly attracted. Paramagnets align with external magnetic fields, while ferromagnets strongly align with an external field. Or electrons strongly align, so it's like a lot stronger. The main difference between the two is that ferromagnetism keeps some of its magnetism even after another magnet is removed, and paramagnets lose their magnetism when the magnet is removed. So an example of paramagnets would be aluminum, oxygen, while ferromagnetism you'll find in stuff like cobalt, nickel, or iron. You'll notice those ones stick out as items that we use for making like electronics and stuff like that.
Those are the three.
Yeah. The reason why they do it that way is because paramagnets have unpaired electrons. So, oh boy. Okay, so how do I explain paired electrons? So, you know what? The closest thing I can think of is that certain types of atoms are more likely to want to lose or gain electrons, because at different levels of like shells, they can get kind of weaker and stronger. Some are more stable, some are less. But for example, so paramagnets have unpaired electrons, but a weak interaction between them, while ferromagnets have unpaired electrons, but they have a strong, what's called an exchange interaction bonding them. So that means that paramagnets tend to have an interaction that's weaker than thermal energy, and then ferromagnets will tend to be very strong, and the electrons will stay aligned. And so, and to the point where ferromagnets, as we know them, can be, you can see them in everyday life. They are what we just will colloquially call magnets.
Yes.
While paramagnets require like specialized materials because their magnetic field is so weak that they're like almost it's almost like you have to like need like lab equipment to detect the magnetism of them.
Yeah.
So here's the main thing. Quartz.
Tell me.
Quartz
Yes?
is not magnetic, is not ferromagnetic.
What?
Yeah. So quartz
That
is
doesn't make sense. They told me it was.
exactly. Well, this is what they're conflating, because quartz is paramagnetic, not ferromagnetic. It is very slightly repelled by magnetic fields, not attracted, and it
Okay.
can't actually hold any of its own magnetism at all. So it can interact with magnets, but it can't
Sure.
really create its own field.
I can interact with magnets. I don't think I'm magnetic.
So like, yeah. And so like talking about quartz as interacting with the magnetic field of the Earth as if it were iron is actually a category error, because granite just doesn't become a magnet just because it exists. Granite is mostly a mix of quartz, feldspar, and mica. None of these are ferromagnetic materials.
Fair enough.
Now, there may be in granite trace amounts of iron-bearing minerals, but they're usually
Okay.
sparse. And importantly for
Okay.
magnetism, they're not going to be oriented the same way. Like their spin is not going to be aligned enough to create a magnetic field.
They're also, importantly, not the things that Ancient Aliens is claiming are the magnet.
That is true
parts.
too, yeah. Yeah. And they're also usually chemically bound into a crystal lattice that prevents a lot of magnetic alignment. So there's no exchange interaction, there's no stable collective magnetic domain, so there's not really any real magnetism. The paramagnetism they talked about that quartz does have is far
Okay.
too weak to actually do any real work.
Okay, but there's like so many of these stones, though.
So the thing is that paramagnetic materials don't create their own magnetic fields. They only align when there's an external magnetic field present, and the effect vanishes when the field is removed. So the claim here is that these things aren't making their own magnetic field, they're harvesting off of the Earth's magnetic field.
From the Earth.
And this is the big thing that we didn't talk about when it came to world grid theory, nor when we talked about Carnac, which is that the Earth's magnetic field is extremely weak when it comes to magnets.
What?
You can tell
That's so
because,
big.
all of the metal things don't just stick to the ground.
That is true.
The amount of the amount that like Earth's magnetic field is so what we measure magnetism with Teslas, and the Earth is about the Earth's magnetic field strength is about 25 to 65 microteslas. So
So not even a full Tesla.
a microtesla is about 1/1,000,000th of a Tesla.
Okay.
So 25 to 60 microteslas. I'm just gonna just to give people like a kind of explanation, or kind of like comparison. You know those
Please do.
those like neodymium magnets that we have and everything now?
Yes. Very strong.
Very
Rare earth magnets.
yeah, the rare earth magnets, but like not like it's not like an MRI magnet that will like fucking rip your head off or something like that.
Okay. MRIs, I don't think rip people's heads off.
They
but-
do not. What's it called? If you like are wearing like a metal chain or something like that.
Okay. That's fair.
I learned this recently about MRIs, and it was so insane. So the way that the magnets in MRIs work are so powerful
Uh-huh.
that, first of all, like,
how powerful are they?
well, like a person recently died because they were wearing like a chain, and they brought it in.
Did it decapitate them? Like you were
I think they
saying?
strangled.
Okay.
But here's the thing.
Still not good.
Yeah, but the thing that's crazy is that MRI machines have to be kept on forever. So what happens is that if you were to cut off the electricity to an MRI machine, the the magnetism in that like powerful magnet that makes it work would quench and it would never be able to become magnetic again. It would just be a complete cover.
Ah.
So there is like a big red button to turn it off, but you only can push it if like somebody is going to die, because like if you push that button, you are basically destroying a $1 million machine. So, but the thing is that it has to like rotate. So like when people are like servicing MRIs, they have to service it while it is still on and moving.
That's wild.
Yeah. So one of your neodymium magnets, strong, but like something that is like a typical thing. you will find that a typical a neodymium magnet will probably have about somewhere between 0.2 and some of the more powerful ones, 1.4 Teslas.
So millions times more, it seems.
Yeah. So let's put the lowest number that I could find. So the weakest of the neodymium magnets, probably like the consumer grade ones, would be about 200,000 microteslas.
There you go.
Compared to the Earth's about 60 at its strongest point.
I guess that makes sense why compasses are so finicky. Like they have to be like balanced on like a tiny little thing or something.
Yeah, because they're trying to align with a very
to,
weak magnetic field. Yeah.
Yes, they have to be able to move it like to pick up these tiny magnetic fields of the Earth.
Yeah, some of the first magnets or some of the first compasses, they actually had to they would put them in water.
In water, yeah. You still do that as like an experiment if you're a child and you're bored on summer break.
Mm-hmm. But hey, that's what let us cross oceans. It's actually quite amazing how such a little trick was able to do so much. So the thing is that this alignment, to kind of talk about, because I mentioned how like aluminum and oxygen are other examples of paramagnetic materials. If the Earth had a magnetic field that was powerful enough that it could actually generate usable energy, the most powerful, like we would have power plants, like basically if these stones at Carnac could be our batteries, then aluminum like cans and ladders as well as like oxygen would also be a battery.
That's true. Oxygen is technically my battery. I guess technically not, food is, but does help me go. Does help me keep going.
Yeah. I mean, yeah, that's a chemical thing, but I appreciate the joke.
Everything is chemicals.
Yeah. So another thing too is that so ferromagnetism is like if you wanted to make a stone that you would call magnetized, you would need some kind of ferromagnetism. And so by claiming that these stones are magnetized implies a type of magnetization that only happens in ferromagnetic materials. And granite can't retain magnetization, and any detected magnetic anomalies are just geological leftovers from iron oxides cooling millions of years ago, not any deliberate engineering. So it's just like the amount of power they're trying to tap into is way too weak, and the materials that they have are not powerful enough to even harness that.
I guess I sort of get where they're coming from. Like with all of these ancient aliens things, there's always like a sliver of truth. Like I feel like we all instinctively understand that like quartz is electric in some capacity.
Yeah, I mean, it
powers
makes
watches. Yeah. So I think there's like they tap into something that feels logically true or like known to a wide audience, and then they sort of extrapolate it out to a weird place, and they're just like, this is true.
Mm-hmm.
So follow me on this weird journey that doesn't make any sense, but
yeah, I mean,
starts from a place of truth.
Yeah, because like this happens a lot with like weird like all sorts of pseudoscience. They'll take something that has either like a small thing to it and then drag it out as much as you can, or take something that's very preliminary and make it way more established. For example, like in this case, as you mentioned, quartz is an incredibly interesting material. It is the source of our digital watches, and it's also like what makes a lot of radio transmitter and receivers work, because they do kind of vibrate in response to radio waves like that. The thing though is that piezoelectricity doesn't make quartz a battery. What happens is that piezoelectric materials are something that can generate tiny transient charges, but only if they're being stressed or deformed. Basically, they kind of partially convert the energy that is being hit by like when they get like crushed or something like that. They convert that into a small charge.
Huh.
They do that. But the thing though is that it has to be like active. It can't just be like something like the weight of a stone. It has to be like it being hit or it being like
Right.
exposed something. So static pressure, like the stones at Carnac, would do nothing. There's no deforming happening there, which means it's not creating any current.
Hmm. But if they were all stacked up like dominoes, like they are, and you pushed them into each other and they just all started hitting each other, then maybe.
Even then it will be a problem, because we kind of get back to the scale thing, like how you can't really use the Earth's magnetic field because the Earth's magnetic field is far too weak.
Hmm.
Even because there's lots of quartz in the Earth, and like even when an earthquake happens, which is probably a pretty large example of stress and deforming,
Yeah.
the quartz and stone, when there are earthquakes, creates an electric current. But the voltages that you're creating are only able to be measured, are so small they can only be measured with really sensitive lab equipment. So like you're not really seeing anything that comes close to what we would actually call any kind of meaningful energy storage or transmission.
Okay.
Yeah.
Fine.
Also, a battery has to have some specific stuff like terminals or a voltage gradient, to make the electron flow happen.
What are you, the battery police?
Today, I am.
All right.
The Duracell
I'm
bunny
so
in a
sorry. I
fucking
didn't realize.
police officer uniform.
I didn't understand the uniform at first. That's it makes a lot more sense now.
It's me and the Energizer bunny. But yeah, like a solid granite block doesn't have a voltage gradient, doesn't have a medium, like a sort of thing that prevents recombination or any terminals. And any piezoelectric charge that would be set off by these things would be instantly disappearing into the bulk of the material. So, and also and if you're trying to argue like, well, maybe the alignments or the shape of them is what gives them the power, but pointed shapes don't focus magnetic fields unless the material itself is still ferromagnetic. You can't synchronize effects that don't exist in the first place,
That's fair. That's fair.
And you can't really scale weak, random, or vanishing phenomenon into a system by just arranging it the right way. So basically, like, even if there was like the materials don't work, and aligning them isn't going to make materials that don't work. And on top of that, they also mentioned broadcasting energy, and we talked about this in the pyramids episode a long time ago, about the pyramids being this wireless transmitter of electricity. And we have talked about this in the past, that this is something that is, it has challenged people for ages. Like, there's a reason why we need to plug in things for the most part, because wireless electricity is possible, but it's very difficult and very inefficient.
It's bad. It's not. Yeah, it's very inefficient.
So like,
and it makes everything hot.
Yeah, because like one example that we do use of wireless electricity is this little thing. This is my phone.
That's a phone.
Because now everybody's got like a wireless charger that they can put on their that they can rest on their thing at night. And that is called induction charging, and that is specifically done because your device has a magnet here and the other device has a magnet here, and they're ferromagnets, and they do a specific thing where they rotate the charges to make to transfer electricity. But they have to be very close to each other. They have to be like touching almost.
They gotta be touching
to work. Not quite touching because they have the plastic between them, but they have to be like the amount of energy that it transfers goes down very quickly over time.
It's millimeters.
Yeah,
it's millimeters. Yeah.
Because like there was like Nikola Tesla had a concept of making like a broadcasting energy, but it just never worked. And even like the most like powerful theoretical ideas that we have for it are really, really inefficient systems. Like one of the ideas of wirelessly powering something, of transmitting electricity over space, would be, there are basically two. One is a laser,
Okay.
If you have like, for example, because like what this is actually like one of the challenges we're trying to figure out right now is because if we could build satellites that collected solar energy,
okay,
we could like, because there's way more solar energy outside of the atmosphere, right? So we could harness way more electricity, and it would we'd never deal with nighttime or anything like that. But the problem is getting the energy down to the Earth. And some of
Down.
the things that have been proposed are lasers, where you use the energy to power a powerful laser, and then you have a receiver on Earth that is aligned with it that kind of turns that light into electricity. But a lot of energy is lost in that connection. The other is using microwaves, which is also light basically in another way. But again, a lot of energy is being lost in that process.
What about long cable?
Main problem is that you would eventually start wrapping around the planet.
What if it moves at the rate of the Earth?
There you go. At that point, you're basically in. You may as well make a space elevator at that point.
That's also true. Long cable. NASA?
You're a
Long
genius.
cable.
Long cable. You'd have to put it in geosynchronous orbit, which is like even further out than low Earth orbit where most satellites are. You have to put it up where the GPS satellites are.
Yeah. But then, just extension cord all the way back to Earth.
You just like have them all plugged into each other, like one by one. Like,
Oh, yeah. Well, that's the thing, right? I know I said long cable, but what I really mean is long series of cables. Because if one breaks, if one is bad, like a bad batch, you just replace it, and you don't have to replace the whole cable. You replace a portion of the cable. Plug it in, plug it back in.
There you go. We've just solved climate change, I think.
I did it. Sorry, I solved it.
Yeah, you know what?
I don't know what you did.
This season we've solved the male loneliness epidemic, and now we've solved climate change. We should be called on to solve more problems.
What's next?
Yeah. So, electromagnetic transmission uses oscillating currents, which is how your phone, your wireless charging phone works. And the thing is that granite doesn't have any way to create conduction. And also, there is no mechanism for oscillation. Oscillation being like a quickly switching between positive and negative charge. It's how alternating current works. That is how radio works. It's how basically everything that's not like, your electronics used. So, okay, I guess we'll have to get into this. So there's two types of ways that we transmit electricity. One is called direct current. One is called alternating current.
And together, they're a rock band.
Exactly.
AC/DC.
The difference between those two is that DC power is directly like one-to-one, like the electricity flows directly from one thing to another. Alternating current means that it is constantly switching between positive and negative. So you don't have to create a complete circuit in order for it to power things. Well, you do, but it's much more stable over long periods of time. This was like the big thing that like Edison and Tesla fought over. But but all of our electronics use alternating current except for computers. So computers need to use direct current. So you'll notice anytime you have like your phone charger or anything that plugs into the wall, you're going to have some kind of little block that gets hot, right?
Yeah.
That is the little transformer that is turning. I don't know if it's actually a transformer, but it is always a thing that is converting an alternating current into a direct current.
Interesting.
That's why, like, if you were to make a cable that just like what plugged directly into the wall and then went into your phone, it would fry your phone because the direct current's what's needed. So there's always a converter somewhere. For example, in your power supply on your desktop, it's in your computer. In your phone, it'll be in the charger. On your laptop, it'll be in the charger. That's the little block on the power cord of your laptop.
Fascinating.
I know. This is like,
I have a box of chargers. Just so many of them.
So you know exactly what I'm talking about then.
I have so many that when my wife, who inevitably loses some because her previous job, she traveled a lot and she always like left them places. She'd be like, oh man, I think I left this at the hotel. Do you happen to have another? I'd be like, yes, of course I do. Of course I do. I have so many.
Exactly. So basically like what Ancient Aliens is doing with this specific claim is that they're conflating a real phenomenon, specifically like magnetism, geomagnetism, and piezoelectricity, which are named correctly, but then blended together as if they are the same with like ferromagnetism. Like just because it has the word magnetism in it implies a level of power that is completely different.
Power, energy, electricity, magnetism. You could use these interchangeably for ancient aliens.
Yeah. In reality, each of these effects, piezoelectricity and paramagnetism, are weak, context dependent, and incompatible with others in the same setup. It's not.
Fucking burn. Got them.
Got them.
They're so weak.
Do you know what's not weak, Scott?
Tell me.
The products and
I'm dying
services
to
that
know.
support this podcast.
Ooh, they're nice and strong. I love them. Let's do them right now. I forgot I was in charge of the button. I feel stronger already.
Yeah, I loved whatever that product or service was.
Do you know what the strongest shape in the world is?
Is it love?
The shape of love. That's correct. I thought you were gonna say triangle. And I was
It's
gonna
chronomancy,
say, nope.
time magic.
It's time magic is the strongest magic of all.
Oh man. Yeah, the main so this is the next claim is we're going to talk a little bit about not time magic, but triangles.
Okay.
The strongest shape or whatever.
I'm guessing. I have no idea. I assume it's a triangle.
Now there's a long history with Pythagorean triangles and what's called sacred geometry that we've already talked about.
Uh-huh.
But the thing is that the claim is that these ancient people in the Neolithic age were able to make Pythagorean triangles 2,000 years before Pythagoras. So they had mathematics that they could not possibly have known at that time without a writing system or anything like that.
Without Pythagoras himself.
Yeah. Aerial surveys of the Carnac stones show large-scale geometric patterns that are formed by rows, circles, and rectangles of stone. And when measured from above, certain endpoints of the alignment, such as the stone circle at one end and the rectangular enclosure at the other, are claimed to form portions of a right triangle. The ratios of the triangle's sides are asserted to match what's called a 3-4-5 Pythagorean triangle, which satisfies the relationship of a2 plus b2 equals c2a to the power of 2 plus b to the power of 2.
A squared plus b squared equals c squared.
Yeah.
Where are my geometry nerds?
Trigonometry.
At? Let's go.
Let's do this.
It's trigonometry? I didn't know that. I guess it's triangles. Yeah.
So the builders of Carnac again, they have this Pythagorean triangle, but they made these positions 2,000 years earlier than Pythagoras, who is traditionally the one we credit with formalizing the theorem of, a squared plus b squared equals c squared. Because the theorem is framed as advanced mathematical knowledge, the argument claims that the builders could not have independently known or applied such a thing. You can probably already tell where I'm going if you've listened to more than one episode of this podcast. But the geometric layout is interpreted, it's not accidental or practical surveying, but a deliberate mathematical message embedded at a landscape scale. And this message is proposed to have been placed intentionally so that a future civilization would rediscover it or recognize the mathematics and recognize the site's creators possessed non-human knowledge. So
cool.
There's two things going on here. One is our lovely Texas sharpshooter, which is that if you take 3,000 stones, like there are at Carnac, and scatter them over a mile's area, it's mathematically impossible not to find 3 that make a triangle of the kind that you would want to make.
I was gonna say, the fact when you were reading this out, you had said certain endpoints of the alignments form this, it's like, oh, okay, so we're just picking and choosing whatever we want.
Yeah, they're just making triangles. The other thing, though, is that what they specifically made were called 3-4-5 triangles. And 3-4-5 triangles, or Pythagorean triangles, are a very common, while Pythagoras made the theory behind them, or expressed it mathematically, 3-4-5 triangles have been seen all over the place, all over history, since way before Pythagoras. So
you ain't special.
Yeah, they're using, so the way that it works is that if you were to take like a rope and make 12 knots in the rope at equal distance from each other.
Sure, hold on, I've got a scarf on. 1 second.
You tie it into 12 knots.
Can you just wait till I tie 12 knots really quickly?
Sure, yeah.
Just one more time. Hold on, wait. And then I have a sound effect, I think. All right, and I did it.
All
And I
right.
got 12 knots in here.
All right. Now, if you were to say, take make one length 5 knots long,
Okay.
another length 4 knots
Oops.
long, and then a
All right,
third
let's see
length
what I do
3
there.
knots long,
And then, okay, yeah.
you would have a right triangle.
Oh my gosh, I did it.
Yeah. Perfect.
Tristan, look at my right triangle.
You did it. And
It's
you know
so
what
good.
else?
What do you think a squared plus b squared equals?
I think it might be c squared.
Oh, shit.
And look, you didn't have to do
That's another
yeah.
thing we solved.
You didn't have to do any math to make that work. You have a 3, 4, 5, and a 12 length, 12 equidistant things. And when you make a right triangle in that fashion, you have also half of a rectangle. So this was a technique regularly used. We've seen it used in Egypt. We've seen it used in Neolithic France to basically mark out squares of territory using or rectangles of territory by putting these down. You make a triangle where one is three things long, one is 4, one is 5, and you'll get a right triangle.
Oh man, so cool.
Yeah, and so
people are smart, man.
yeah, and you didn't have to use any math to actually figure that out. It's pretty common. For example, but the thing is that like it's not even the oldest example of a 3, 4, 5 triangle. It's found in Le Carnac, which is an egg-shaped stone circle. It's found at the Manio site. There are again lots of Neolithic examples of these things happening. And yeah, this does predate some of our earliest examples of the Pythagorean triples, which we see in Babylon, still before Pythagoras. And this also is before
what did
Pythagoras
this
by
guy
about
even
4,000
do?
years.
What is this guy even good for?
He was the first white guy to write it down.
That we know of.
That we know of. But the thing is that, yeah, again, this is a really common rope stretching technique that was discovered because it's very good for practical early surveying work.
Yeah.
And so, and the thing,
It's a fashionable way to wear a scarf, I'm learning.
yeah. Aside from just being a scarf, though, it's used for creating square corners. So this was commonly used in construction, for building, or for land boundaries. So there were a lot of other practical uses for it as well that don't need sacred
right
geometry
angles.
or power to do so. Yeah.
Yeah, awesome.
Because, again, if you take a rope with exactly 12 equal segments, knotted, you can make a 3, 4, 5. Yeah,
Tristan, I just unknotted it. Okay, one more time. Yeah.
it always creates a perfect 90-degree angle.
Yeah.
There's no complex
That's
math.
really
You don't
cool.
understand why it works, just that it consistently produces right angles, which is the thing you're going for.
That's what I'm going for.
So that's the math. So the Pythagorean theorem thing is not actually like, it's impressive, but not like in a way that is outside of the ordinary. This is a pretty common technique that people have discovered and redone over and over again. The next part is the idea that it's part of a world grid. So they had the claim that certain locations on Earth are said to possess naturally higher geomagnetic or electric properties, sometimes described as vortices or sacred energy points. Again, energy not in any way that can be measured by any scientific instrument, so it's nice and unfalsifiable.
It's energy, man. Just feel it. Feel the vibes.
Yeah, and this has been formalized into what we've called, what we've done in previous episodes, world grid theory, which proposes that these locations form a planet-wide network analogous to the longitude and latitude lines, or ley lines. Many ancient monuments are lined up along it. Carnac sits alongside Giza, Machu Picchu, Baalbek, Stonehenge, etc.,
Yeah.
which are claimed to be positioned precisely on these grid points, implying some kind of intentional global coordination. Again, the Carnac stones are these, according to them, magnetized quartz-rich, deliberately shaped, allowing them to interact with this field, and that their rows are interpreted as a design for detection, and just all this stuff. And the thing is, though, there's no evidence that this was like the logic one is that one, granite's an insulator, not a conductor of electricity. So, and there's no wires. Like the thing is that you need the context around it. And we know that electricity doesn't move through air very well. It doesn't move through granite because, the resistivity of granite is more than 2,000 ohms. And dirt is also not a great conductor of electricity. So there's nothing that is actually making that electricity move from one place to another. And on top of that, like, if there was infrastructure for converting the world grid into actual electricity, there would be evidence of that. There would be the power stations, the lines, the wires, any devices that even used it. Like something would exist, right?
Oh, Tristan, this is your mistake. You're hearing world grid theory, you're hearing about this energy, and your simple mind goes to electricity. It's not about electricity, man. It's about the energy. You just feel it. It's about the vibes. It's about the sort of magic essence between these places. Electricity, that's a simple-minded human concept. This is energy.
See, if the ancient aliens people could just describe what they mean by that and how they would turn that energy into something that's actually able to do something, then we're having a conversation.
No, you just gotta feel it.
You just gotta have the Christmas spirit in you.
Can you feel it, Tristan?
No, that's the problem.
Okay, well, guys, I tried. I tried with this guy.
And like, to kind of like look at this, like the physics shows this is impossible. The geology says that this is not going to work. So then why do we want it to work? And
this sounds like a part of the podcast with a musical sting.
Yeah.
Right?
Yep. Oh.
Tell me.
So the thing is that the thing that stuck out to me, because we've talked about like, oh, like this is like bad, we've talked about using pseudoscience. We talked about the bad use of logic here. But why are they so obsessed with turning this, beautiful, mysterious site into a power plant? Like, why is, like, basically, I feel like, Scott, you're going to really like this kind of thing I came to. But it's like,
okay,
why is it that they have this inability to look at a human creation and not ask the question, what does it do? First of all, there's a presentism of like us projecting modern ideas backwards, connected to what's called capitalist realism. The idea that the value of something is based on its utility, not on any other sort of
Let's go, Tristan.
Yeah, because the thing is,
you're in your element now.
Yeah, well, the thing is that we live in a society. But we live in a
we do that. Yeah, it's true.
We live in a civilization that is so preoccupied with productivity and with utility and function that we look at these ancient sites and we have trouble trying to think that maybe these things don't have a utility. Like, even when we like look at like Stonehenge, we have to think, well, it was an ancient computer. It doesn't have to be a computer. Here's the thing. Carnac, we aren't 100% sure what it is, but we're decently thinking that it's probably, at least in some capacity, a cemetery. It's a procession. Thousands of people who dragged these 300-ton stones didn't do it because they wanted to charge their phones or something, but they wanted to remember the dead or to walk in a line and feel something. And this is the tragic thing about Ancient Aliens' worldview, is that it's hollow. It looks at a monument to love and grief and asks, yeah, but how did they use it to make power? Or what did they use it for? And, and the whole idea is that, we're millennials and we should learn, even though we're doing a podcast, which is sort of the opposite of this, that like, you don't have to turn your hobbies into a side hustle, and you don't need everything. Like, everything doesn't need to be a machine to be valuable. And so this doesn't need to be a battery. This is art. not done for a utility or a purpose. It's done as a form of expression to make people feel something.
This is a really good point. I made a video not too long ago about this book talk drama, and in my video, I mentioned briefly about how I feel like, because this author in this book talk drama was talking about how they had 1,000 hours or 10,000 hours of, writing experience, and like, oh, that must mean that I'm a master of my craft because I've worked so hard. And I sort of attribute this to being like, this is also sort of a capitalist thing of a thing is valuable because, it took so long, like because effort went into it. And I also feel like it's part of the reason why a lot of, bringing it back to art, I feel like I mentioned that it feels very similar to why a lot of conservative people who are big into capitalism don't like things like modern art, because in their eyes, it didn't take long to make and it didn't take a lot of effort to make, and therefore it's not valuable. And I feel like this has a similar idea of like, there is this sort of capitalist thing to be like, the value of something is like, what is its utility? And then outside of its utility, if it is art, then you must have had to spend, months and years on something for it to be valuable. Like there is this like tendency to be like, even if they see something as art, it's like, okay, but it has to look like you spent a long time on it. But then, yeah, it is this idea of, I feel like before they even get to that, it's just sort of like, well, what is this utility? What is this? Even though art isn't, anyway, yeah, I just feel like, does this make sense at all of what I'm saying?
Yeah, I mean, like it also speaks to like how the same type of right will be against like abstract art, because they're like, well, it's not a depiction of something. And it's like, well, art doesn't have to have a function like that. It can be made to, again, things don't have to have a utility, a productive utility. Sometimes things are just made to make you feel something, or to get across.
Yeah.
Like sometimes some great pieces of art are just like, I just kind of wanted to figure out this color. And
yeah. And I think that sort of is the thing that marries these two ideas, is this sort of like productivity around it of like, are these rocks that are just in the middle of a field? What is their productive value? What is their utility? What do they do to make the society more productive? And it's like, probably nothing. Probably it's just art, or some sort of spiritual thing or religious thing or whatever. And in that same way, yeah, it does feel like that with like modern art or just anything like that. Abstract art, where it's like, how much how much effort did you put into this? And it's like, I mean, sometimes a lot, but sometimes, and I know that this is a controversial one, but I mentioned like the banana taped to a wall, and I was just like, I don't know, man. In my eyes, it doesn't matter how long or short it's something took to make. If it evokes an emotion,
which the banana definitely does. I mean, the most famous example is the urinal.
The urinal. Which I should have mentioned the urinal.
Which is
the banana taped to a wall. Got a lot of comments from people who don't like my take on that. But anyway,
the urinal is the famous one, because the whole idea isn't the piece itself; it's the fact that that piece is in a museum. That is the statement. Like that is the whole,
exactly.
Yeah, but yeah, like this is kind of as me just rewinding it, because we're coming to the end of this. We're at the end of the season now. We're going to be starting off with a new subject, which is an episode called Ancient Devastations. I think that's what it was called. Yeah, the next one is called Alien Devastations, awesome. Which makes me think we're probably going to be going back to India with Brahma weapons and stuff.
It also makes me feel like I'm going to use this button a lot.
Oh, Mr. Nolan, thank you for coming.
Mr. Nolan's here. Hey, buddy.
He knows
You're
how
going
to-
to join us for the next session.
Yeah. But like reflecting on this season, we've looked at several subjects where like a lot of the times they're trying to make something a historical record. They're trying to make something like some kind of device or have some kind of mystical property, when like a lot of them are like even like last episode, Coral Castle. It was a project from somebody. Like he didn't do it because he wanted to make money. He did it as like a sort of, because trust me, if you're a trained stonemason, there are way better ways to make money than what he did. But like
Exactly.
he wanted to create something. It was an art project. And like
Yeah.
we've seen with Carahunge, we've seen with like, well, you didn't see with Carahunge, but we've seen with like a bunch of our other examples that like there's this attempt to give things a function when these things didn't necessarily either need a function, or their function was not necessarily something that we would think of as utility in like our sort of strict capitalist mindset. And that sometimes people do things because the act of doing them is valuable, or just or you're just like trying to build, or you're just reflecting an idea, a message, a feeling. And
Yes.
I think that that's like the big thing I'm going to walk away from, is that, you know, the life lesson for everybody here is do something that is deliberately not productive.
Oh, hell yeah.
I'll give you one good example. I'll give you one really good example that I like to do, and this is my personal thing. And I think I've mentioned this to you privately, but I don't think I've said it in public. And that is that most people will know through like occasional references and stuff that I am like a gigantic role-playing game fan. I love me a D&D. I'm like always running at least one campaign. Right now I'm running 2, and I like love this shit. I buy way too many role-playing. I literally like, there's like Stanford, the editor of this podcast, this season of the podcast, sent me some Warhammer 40K dice.
Nice.
But like I've got the Daggerheart rule book right next to me. And like, but here's the thing is that with the exception of like the kind of the things we did with Phil, I intentionally like have resisted the idea of turning my role-playing game stuff into content. I have I've resisted any urge I've had to make an actual play show. I haven't resisted the idea of potentially developing something someday, but I feel like that's a little bit different. But I haven't like made like a channel or anything like that. And the reason is that I intentionally try to keep it, and I put a lot of effort into it. Like a lot of my creative energy goes into running this stuff. And it's because I like making something that makes my friends happy. And I intentionally try to keep it outside of the things that I do to make money. And I think that has been key to me enjoying it and having a deep connection with that hobby, because it has no end goal other than to be an artistic outlet and to be a way for me to make my friends laugh and smile.
I love that. I think there's a lot of stuff like that for people, even if you don't think about it. I made a video all about Bob Ross a couple years ago, and that was sort of the
your painting that you'll never show anybody.
Spoilers for that video. It's several years old, but like I paint a painting in it, and to me the idea of Bob Ross was like not turning hobbies into a side hustle, as you're saying, and just sort of doing it because you want to. And so I wish I continued painting, but it's just hard when you don't have the space to, beat the devil out of the brush and get paint everywhere. But it's, I would say, I think a space that I found really interesting, and not that I use it, but I find the concept of it interesting, and maybe I will use it, I don't know, is like, I think Letterboxd is interesting just because like it is like a thing where you can get some creative, if you're a movie lover, you can just like write, a creative review, or just like write your thoughts out about a movie. And it just doesn't, as far as I understand, nobody's made a career out of letterboxed reviews. Maybe they have, but I think that's an interesting space of just sort of chronicling not only the movies that you're watching, which is like a thing that you can do just for fun as a hobby, but also creating something by writing your reviews and your thoughts down and again, like not turning it into a job necessarily. I think that's interesting. For me, I just like to sing. I just like to sing in my spare time. And that makes it into, I think I've sung in like 2 videos total, maybe. But otherwise I mean, if I'm home alone most of the day, and so I just like blast music and I sing and I have fun, and it's just like a fun thing that I do that isn't part of my job.
Yeah, I learned at your birthday party that you play guitar. And I don't know how much
I
you
do play
noodle around with
guitar.
your guitar and write stuff out for that, but
I need to do more of it. I need to do more of that. I have this idea in my head that I want to play songs for baby when baby's born. So I'd like to do that. Also, yeah, like learning another thing for me, learning close-up magic. I love that shit.
yeah.
It's so good.
So why don't
Do
you
something, find something. Yeah. Yes, find something for you.
be useless
That isn't. Be useless for a little bit.
and tell us what useless thing you're doing by tagging us at @probsnotaliens on Blueski.
Exactly. Gosh, my wife is the opposite of productive right now. She's producing a whole human, so I don't know what she's got going on. Tristan, you've got stuff that you do outside of this podcast.
I do. Yeah,
What's that about? Tell me about it for the first time.
I have a YouTube channel called Step Back that has been dormant now for over a year. But I was talking about this with Scott. As of the recording of this podcast, I sent my resignation letter to my boss, or I have it scheduled to go out on Friday. And so I am ready to get back into the game and to have at it. And so I'm hoping to, starting in February, start making stuff again. And I have a few things in the fire and I'm pretty excited about it.
I am excited to post, as soon as you post a new video, I'm gonna post a meme that says, from the Star Wars, that just goes, somehow Step Back has returned.
Nice. That would be like Tychus Finley going, hell, it's about time.
Mm-hmm.
Scott, if I wanted to learn how to make my own pre-keyed footage, how would I do that?
Jesus Christ, man. What is that, for like 12 years ago?
Maybe.
That's insane. I have a YouTube channel called NerdSync, NERDSYNC. I used to make After Effects tutorials on that channel.
There's still one on there
anymore. I left them up because people found them useful. But yes, my the main thing I do now is video essays about comics and cartoons, and sometimes not even full essays. Sometimes it's just me reacting to stuff unscripted because I gotta make more videos and I got a baby to support and feed. Not yet, but I will. By the time you're listening to this, I probably do. So yeah, that's my YouTube channel, NERDSYNC. I think I already spelled it once. You can also, by the way, support this podcast. If you're like, oh, I want to support Tristan and Scott, but how can I support them to like both at the same time? Don't make me choose between NerdSync and Step Back. First of all, you do have to choose. You can only be subscribed to one of us, but you can support both of us by going to this podcast on nebula.tv/probablynotaliens. That's where you can get episodes early and bonus content and things like that.
Q&A next week for you.
Streaming service. Yeah, it's also just a streaming service with a bunch of other cool creators and stuff. I say a bunch. I mean, like literally hundreds or maybe thousands. Probably not thousands. I don't know. You can support us even more directly, this show, by going to patreon.com/probsnotaliens. Again, all that same good bonus content, early episodes, but it's just a more direct way to support this show in particular. I also just like, I don't want to brag, but I kind of do want to brag. But we learned recently that we're like one of the most listened to podcasts on Nebula, by the way. So like, thanks to all of you. Thanks to all of you who do that. That helps us out. If you don't have any money to throw away, hey, who does these days? Am I right? A great way to support the show for free is just write a nice review of this show on Apple Podcasts, on
Gooby.
I don't think Spotify
on
does
Debo.
reviews. On
Blorpus on Debo.
Tubi, on Fubo, on yeah.
Blorpus
It's
on
actually
Debo.
really funny. That's pretty good.
Or what's it called? Bleat us on
Rebleed
on
on goat. Rebleed us on goat,
Yeah.
please. And if you've already written a review, tell your friends about the show. If you've already told all your friends about the show, tell them again.
And
They
tell
didn't
your enemies
listen.
about the show.
Tell your enemies about the show. They did listen. They're just stubborn. A great place to send people is probsnotaliens.com. It's got links to all the things we talk about at the end of the show. So send them there. Do it. Do it. Until next time, until next season, my name is Scott Nicewater.
I'm Tristan Johnson, and the truth is out there. Probably. This is a goat. Rebleed us on
This is a
goat.
goat. Rebleed us on goat.
Spelled
what
G-O-A-T.
episode was that from? That was one of the
Wait, that is how you
funniest
spell
jokes
goat.
I've ever made. It's the greatest of all time. It's the greatest social network of all time.
It just reminded me that somebody. So I was hanging out with somebody. I was hanging out with my friend Sophie, and she came up with the concept when I was talking about throat coat, the tea. That she was like, you should invent throat goat tea, and I was like, that would just be like drinkable poppers, and that's what I'll end the season on.